Hi, my name is Bryce Saunders, and this is the final presentation for Physics 177. So here are the two versions of my output for my code. We have version 1 over to the left, and then version 2 over to the right. Version 1 and version 2 have quite a drastic change between the two. Version 1 just shows position, while version 2 shows position and a alternating pattern between channels. And so why was it important for me to change my code? So the purpose of my code was to reflect real world dimensions of the prototype detector and aid in simulations for particle collisions. So if my code was acting as though it was for my version 1, we would not be able to see that, as it would not be reflecting the real world detector and how the detector looked in real life. In version 2, we fixed that problem in where it does look like it does look like the full prototype detector in real life. So then we also ensure that my code reflects real world because it is important. So if it doesn't reflect in the real world, the data that is being collected would be incorrect or inaccurate because my code would be incorrect or inaccurate. And so how did I decide the dimensions to be used for this code and for this prototype? So I got a lot of help from a grad student in my lab. So big thanks to Sean. He assisted in providing for the dimensions and the spacing, as we can see here. We can see our alternating pattern in the first image, the two different plates or the two different boards. We can see the thickness of the iron blocks and the tiles, thickness of the iron block and the board, and then we have the thickness of even the tile. And so these were the dimensions that I was provided, and with that I was able to come up with an X, Y, and Z coordinate system to be able to map this entire structure. So the X, Y, and Z coordinates. We have channel numbers, channel index, board. We have X, Y, Z pairs, X values, and Y values. These are all variables that I'll be filling in to what they're used for. So using the dimensions that was provided, we can assign a variable that is going to create a list of all of these X and Y values. These are manually inputted values, and we can easily change them in my code. This creates a variable that will be used to cycle through each X and Y value. This value or this variable is what we call our XY pair. We are going to be using this so that we can iterate through each of the X and Y values. We then create a dictionary to store channels and assign layer mapping. We then get X and Y from position cycle and the Z position from the layer mapping, and then we append those values to a dictionary. So I'm going to kind of summarize what this is. If we look over to the right, we can see our cycle position variable, which cycles through the X, Y pairs, which it's going to iterate through all of the X values and all of the Y values. We then assign position values is equal to a dictionary, which is where we are going to store these X, Y, and Z pairs so that in later time we'll be able to call on them. And so it's a simple loop where we loop for every channels and channel numbers. We then split board and index so that we can just use those independently. And then we check the index is in between 0 and 12, 13 to 24, 25 to 37, 38, 49, 50 to 63, and then we assign those to either an upper layer mapping or a lower layer mapping, which this depends on the channel index and is very important because this gives us our staggered look. It shows where the position of the board is going to be. And then we have layer 0 equals to 0, which is just a fallback. If it increases past the layer, it restarts. And then we have very interesting layers in where we manually assign those towards the end, which is board and 1 to 2, which is equal to layer, which is equal to 4, layer 19, and then layer 14, which is, super interesting. We then get XY is equal to next position cycle, and then Z layer mapping layer, which gives us our X, Y, and Z positions, which we then save to our dictionary. And so we use a very similar structure to how we assign board mapping. We assign a variable of max of 25 so that we won't have to worry about having more than the 25 we expect. So we have a 5 by 5 for each of the layers. There are 5 tiles by 5 tiles. So we expect 25. So I assign this to make sure that there is only going to be 25 and no more or no less than that. We then assign a variable that is going to be used to track the layer number, and we simply did what we did in the last slide, but with assigning a slot. So we have board and channel. We map those and split them, so we get a integer value for the board and the channel. We then check if the channel index is in between our values, which if it's in between 0 and 12, it's A. 13 and 24 it's B, and so on and so forth. And then we have our special channels that need to manually be assigned, which we do so by checking the remainder, and then we assign those directly. We then also, towards the end, count layer counts layer, which counts the amount of layers. So when it does hit the max value of 25, it stops this entire loop. We then get our XYZ position values from the dictionary in our previous slide, and we then get our orientation that we were given from the previous slide as well. So the difficulties working with this code. I have worked with code in the past, but very little. I took one course on Python when I was a junior, in which I did decently well in that, and so I'm a little bit rusty when dealing with code, but this definitely helped rejuvenate my passion and help me relearn some of these subjects. This was my second major project that I worked on. I did only one beforehand, in which I used a data table and analyzed like probability and other situations like that and trends. So this one was definitely more in depth and took a lot more time. Understanding, applying different methods to get the outcome that I wanted. So this was a very open-ended project, so I needed to be able to come up with the question and the answer and the solution to all of those things. And so it was very important to me to understanding how I can get the outcome that I wanted and how I could go about doing that. Dealing with unfamiliar errors and running into near dead ends. So a lot of this code did come down to troubleshooting. I went day in and day out trying to look for things that were going wrong, looking for issues. A lot of the time, the issues did come down to formatting or labeling, in which I got confused with variables or other things, which I addressed later on. I really should work on my labeling and how I address things when I'm running code. And then using a graph to print out a program, projection of the prototype. I've never done that in the past, and so this was a very good and big step for me. So future improvements, things that I would love to see done to this code. A major improvement is how I over-rely on if else, and else statements. I feel as though my code could have worked a little bit better if I understood loops a little bit more and how to implement them into my code. Using the loops would definitely make it more efficient and less cluttered, and so it would be a lot more visually appealing to look at. Clarity with the naming conventions, as some names are confusing and create issues when coding. This is where I ran into a lot of bugs and a lot of issues, is with my naming conventions. I need to make sure that my names that I'm assigning to variables are very clear and concise, and so that these issues will not happen in later iterations. Better code layout. I don't think it was necessary to code all of this in one block, as Jupyter Hub allows different cells that can interact with each other. I think what would have been better was for me to have several different cells that call each other, and so it would be a lot more concise and clear, and so it wouldn't be all in one block that's kind of cluttered. Improving clarity of the output graphs as it's difficult to distinguish visually. Looking at the graphs, there are some difficulties to see the alternating pattern and other things like that. I would most likely go back and see how I can make this more clear or try to fix some of those problems. So additions that can be added in the future. Some of these are interesting or ambitious, and some of them are minorly easy to do, which, is all about those goals. So I would love to make this code more interactive. I think just looking at a blank graph that can't move or can't zoom in to tell features is kind of boring, and I would love to be able to implement something that has like a slider or a zoom feature and some more color. Update and add more layers so that you can see the full scale. This code does not account for some layers, as it was made before we added more layers on top of it, and so I would love to be able to implement those layers and see how much larger this image gets. Add a feature so we can see overlapping layers. So being staggered, having our board staggered, there's definitely going to be overlap in the layers, and I would love to be able to see the layers that are causing some overlap. Add sounds or something while interacting with it is also something that I would want to do and would be minorly interesting for me to code into this program. But I first would need to make sure that my code is interactive. Add some form of tracker. So I would love to be able to say like, oh, I want to track this point in this amount of time. What happens to that? If I could add some form of tracker, that would be super beneficial, as you can make sure that that one point isn't moving around or changing up. And then of course, any other interesting features, I am open to suggestions and would love to hear back from people. And so these are my final thoughts. These projects results pleased me, as you can see in my final version produced the expected results and the correct pickle file. So it was the expected results and it had the expected format. So I'm very pleased that I was able to get here with the help and assistance that I got. Although there can be improvement, I think it was a good step forward in my coding adventure. I think this was a great project for me to have a good foundation to work off of, and will allow me to build off of and have more experience elsewhere.